Hello students, welcome to Akshar IIT classes. So today we are going to discuss the continuation topic of vectors. So already we have completed vector addition, we have completed now in the previous classes. So next topic is multiplication of vectors. Multiplication of vectors. So we have seen there if the vectors are added, we got a vector quantity only. So in the multiplication it may be different there. Okay. So if the two vectors are multiplied, so the resultant it may be the vector quantity, you may get the vector, or the scalar you may get there. So we know that vector is nothing but it is the physical quantity which has both magnitude and direction and which obeys the law of vector addition are called as vectors. Okay. So we have many physical quantity in our physics will use. So in that some of the physical quantities are classified into vectors and other physical quantities are classified into scalars. So we know that scalars are nothing but the physical quantities which have only the magnitude, there is no direction, is called the scalars there. Okay. So we'll see there dot product, multiplication of vectors. In multiplication of vectors, so there are two methods are there. In two ways we can multiply the vectors. So first one is scalar product, or it is also known as dot product, scalar product or dot product. That is a first method to multiply the vectors. And second method is vector product or cross product. Okay. So there are two methods are there to multiply the vectors. So first one is the scalar product and next one is the vector product. So scalar product is also known as the dot product and the vector product is also known as cross product. Okay. So today in our class we are going to see the dot product. So first one we will see there. So first topic, that is scalar product or dot product. Scalar product or dot product. Scalar product or dot product. Okay. So if the two vectors are given like this, suppose let us consider here two vectors are there. This is a one vector, let us consider it is a bar vector and this will be the b bar vector. A bar vector and b bar vector are there, and the angle between the two vectors, let us consider theta. The two vectors are acting at a point in this, the angle between the two vectors is theta. Then how to multiply these two vectors? How to multiply the vectors? Okay. So these two vectors can be multiplied. By taking their component. Suppose we can take here to make the component. To take the component, we have seen there in the resolution of vectors. We have seen now. So this is a theta, angle between the two vectors, and here the magnitude of these vectors can be taken as a here. Magnitude of these vectors. Magnitude of this vector, it is b. So let us consider this is a b vector and this will be the a vector. B vector and a vector. Okay. So let us take this is a O and this point is a P and here this point is Q. So we can take like this. This point is P and it is a O and this point we can take Q. So now here we got a triangle, right angle triangle. So here the angle between them, it is a 90 degrees. So here the angle is 90 degrees now in this right angle triangle. So to multiply them, so the multiplication can be denoted as like this: a bar dot b bar, a bar dot B bar, A bar dot B bar. Okay. So A bar dot B bar can be multiplied by taking the, suppose this is a component A component is the magnitude of the vector A and this B is the magnitude of vector B. Okay. So now we'll write here in this vector, in this triangle, in right angle triangle, from triangle OPQ, in the triangle OPQ, if you apply the cos theta there, if you apply cos theta, we'll get here. So adjacent side, this is the magnitude, we can write here A, no? A divided by the hypotenuse we can take here, this will be the hypotenuse, so that can be taken as B. So from this we can write here A is equals to, if you send this B, if you send the B this side, so it will become B cos theta, B cos theta, B cos theta. Okay. So now the component of B along the A bar can be written as A, that is equals to B cos theta, that is equals to B cos theta. Now the product of these can be taken as product of these two vector A bar dot B bar. So we'll represent between the two vectors dots. We'll put a dot here in between the two vectors. That is the reason why we'll say here dot product or the scalar product. Why we'll say it is a scalar product? The multiplication of the two vectors will give the scalar value. Resultant of these two vectors can be given as scalar value. Okay. So here you see now the dot product of these two vectors can be written as magnitude of vector A, magnitude of vector A and magnitude of vector B, magnitude of vector B. And the cosine angle, cos theta, cosine angle between the two vectors is called the dot product. So this is A bar dot B bar is equals to AB cos theta. So the dot product or the scalar product can be defined as, it is the product of the two vectors, product of the magnitude of the two vectors and the cosine angle between the two vectors, cosine angle between the two vectors. So here we can say the component of this vector is a B cos theta along the A direction, that is A B cos theta, we can say there. Okay. So here the magnitude of this vector A we can write here B cos theta, A is equals to B cos theta, component of the vector A along the A direction is said to be the A is equals to B cos theta. Now this will be the definition of the cross product. So if the two vectors are given and the two vectors can be multiplied by the product of the magnitudes of the two vectors and the cosine angle between the vectors, cosine angle between the vectors is called the scalar product or the dot product, scalar product or the dot product. Okay. So now we can see here, we have seen there now like this. So in the right angle triangle A is equals to B cos theta we got there. Even we can find out, so by using here, even we can find out from this. So if I draw a normal line from this, from here to here, if I draw a normal line from this vector, from here, if I draw a normal line like this up to here. So here we'll get a right angle triangle. So another right angle triangle, let us consider this will be the R, consider that is R and this will be the S. So we got here one more right angle triangle, that is OSR, OSR, okay, OSR. See here, OSR is one more right angle triangle. Now in this B component will be the adjacent side. So if you write here, same in this direction, if you write here cos theta value, cos theta is equals to adjacent side, this OS will be the adjacent side. We know that cos theta is nothing but adjacent by hypotenuse. Now in the triangle OSR, I'll write here in triangle OSR, the triangle OSR. So cos theta is nothing but adjacent, OS divided by hypotenuse is here OR we can write So that is equals to cos theta. Here OS is nothing but what there? B. OS will be the B and this one. Here OR will be the A, component A. So here we can write B divided by B by A. So now therefore from this here we can write there B is equals to A cos theta. B is equals to A cos theta we can write there. So here this B is equals to A cos theta is nothing but component of vector A along the B vector, component of vector A along the B direction. Okay. So this has, we have seen in the resolution of vectors, from the resolution of vectors only we can get it there. So now the dot product of the two vectors, it can be defined as the product of the magnitude of the two vectors and the cosine angle between the vectors is called the dot product. Okay. So note down this one. So next we will see there what are the properties this dot product has. The properties of dot product we will see there. The properties of dot product. Completed now? We will move on to next topic. So properties of dot product. So the dot product has the properties like it will be obey the commutative law. So dot product obeys the commutative law. So commutative law means we will say like this, the first property of the dot product is it obeys the commutative law. So it obeys the commutative law. Commutative law. So what is that commutative law? Means here if the two vectors, dot product of the two vectors A bar dot B bar in this order, so that will be equal to, even it will be equal to B bar dot A bar also, B bar dot A bar also. So this is a commutative law. It obeys the commutative law. So commutative law is nothing but A bar dot B bar is equals to B bar dot A bar. That is the first property of the dot product. Okay. So now the second property, it obeys distributive law. It obeys distributive. It obeys distributive law. It obeys distributive law. So what is the distributive law? We will see now. So distributive law is nothing but, suppose here A bar dot, A bar vector is multiplied, A bar vector has multiplied B bar plus C bar, B bar plus C bar. Okay. A bar vector is multiplied B bar plus C bar. So it is equals to A bar dot B bar plus A bar dot C bar, A bar dot C bar. So A bar dot B bar plus C bar is equals to A bar dot B bar plus A bar dot C bar, A bar dot C bar. So this is a distributive law. This will be the distributive law. So it is also obeys the distributive law. It is also obeys the distributive law. So the dot product will obeys these two laws, commutative law and distributive law. And here we have the some more properties. So third one is, third property, the resultant of the dot product. The resultant of the dot product will be depend on the theta, the angle, cosine angle between the two vectors. So we have seen the formula now, that is A bar dot B bar, A bar dot B bar is maximum when when the two vectors in parallel, when the two vectors in parallel, when the two vectors in parallel. So when the two vectors in parallel means, suppose the vector is there, it is the vector a bar, and another vector, let us say another vector also in the same direction. This is a b bar vector. This is the b bar vector. Okay, another vector. So let us see here, this is a b bar vector. So now what is the angle between them? Angle between them, here there is no angle, no, it is 0 degrees, no. There is no angle between them. Angle is 0. Angle between the two vectors is 0 degrees. So then we'll get the maximum value. So maximum value. So a bar dot b bar will get maximum. So here a bar dot b bar is equals to, we can write here ab cos theta from the definition of the dot product. From the definition of the dot product, a bar dot b bar is equals to ab cos theta. So if theta is 0 here, so we know that here ab cos 0 degrees. Cos 0 value how much? The cos 0 is 1. So therefore we'll get here AB since cos 0 degrees is equals to 1. So therefore you will be get here a bar dot b bar maximum that is equals to AB. That is equals to AB. Okay, a bar dot b bar is maximum, that is AB. Okay, when theta is equals to 0 degrees, that means both the vectors are parallel to each other. Or we can take here these two vectors may be like this also. A bar is, this is a bar and the b bar is like this, even though the angle between them it is 0. The angle between the two vectors is 0. In that case also, then we will be get the resultant of the dot product will be the maximum. Okay. So now when we'll get the minimum, that we'll see there. Is it clear? So now next law we'll see, that is, so fourth law, a bar dot b bar is a minimum, a bar dot b bar is minimum when the two vectors opposite to each other. Means here one vector is in this direction and other vector is in this direction. Let us consider this a bar vector and this will be the b bar vector. Now the angle between these vectors will become theta is equals to 180 degrees. No, theta is equals to 180 degrees. If the two vectors are in this direction opposite to each other, then we'll get the minimum value. We'll see there how. So here a bar dot b bar, from the definition of the dot product, magnitude of the product of the two vectors and cosine angle between them, that is a cos theta. So if we write here, so AB cos of there 90 degrees, cos of 180 degrees, We know that cos of 180 degrees value will be minus 1. Cos 180 value is minus 1. No? So this is equals to, we'll get here AB minus AB into minus 1. Since it is cos of 180 degrees, is equals to minus 1. So therefore the minimum value the dot product of the two vectors will get the minimum. This is the minimum. Dot product of the two vectors will be the minimum. That is equals to, we'll get here minus AB, minus AB, minus AB. Okay. It's clear, no? Now next one we'll see there. Dot product of the unit vectors along x-axis, y-axis and z-axis. Dot product of the unit vectors along the x-axis, y-axis and z-axis. So we know that this is a coordinate system. No? Let us consider this is a x-axis, and this will be the y-axis, and this is z-axis. Okay. So now the unit vector along the x-axis, we know that is I cap, I cap. So the unit vector along the y-axis, it is j cap. The unit vector along the z-axis, it is k cap. Now, so what will be the dot product of these unit vectors? What will be the dot product of those unit vectors? See, we can take here, suppose I cap dot I cap, I cap dot I cap, I cap dot I cap. So according to this formula, A bar dot B bar is equals to AB cos theta. Here there are the unit vectors I cap, and I cap is a unit vector. If it is a unit vector, we know that the magnitude of these vectors is 1. The magnitude of these vectors is 1. So we will write here magnitude of the vector. No, A bar dot B bar is nothing but product of the magnitude of the two vectors and cosine angle between them. So here I cap dot I cap, the magnitude of that is 1, and magnitude of I cap is, again it is a 1. Then cosine angle between them, cos theta. So what is the cos theta here? I cap. So both the I caps will be in the same direction, no? In the same direction. They are parallel to each other, and one will be overlap another. Then we will get here theta will be 0 here between this. Theta will be 0 degrees. If theta is 0 degrees, we will take cos 0 will get here. If you write here cos 0 degrees. So we know that cos 0 value how much? So I cap dot I cap will get I cap whole square, I cap whole square, that is equals to here 1 into 1 into here what will get there? 1 into cos 0 value 1, cos 0 value 1, since we know that cos 0 degrees is equals to 1, cos 0 degrees is equals to 1. Okay. So therefore we can write here I cap whole square, that is equals to I cap dot I cap, I cap dot I cap is equals to 1, I cap dot I cap is equals to 1. So similarly we will get j cap dot j cap also will get 1, because it is j cap is the unit vector along the y-axis. Now if you take same unit vector j cap, then both are will be the angle between the two vectors, it will be 0, same will get there, same value there. Okay. Similarly, so up to here you write on there. Similarly, we will get j cap dot j cap is equals to 1. Even the k cap dot k cap is also 1. K cap dot k cap is also 1. Okay. Completed now this one. Now, so next that one we'll see there. J cap dot continuation, it is j cap dot j cap is equals to 1. Similarly j cap dot j cap is equals to 1, and k cap dot k cap is equals to 1. K cap dot k cap is also is equals to 1 there. Now we'll see there. So what will be the different same kind of unit vectors are have done the cross dot product, then we got here one there. If different type of unit vector has multiplied product of them, then what it will be happen there, that we'll see there. For that also we'll take here same coordinate system. This is the x-axis, the y-axis you take, and this will be the z-axis. This is the z-axis there. So We know that here this is the unit vector along the x-axis I cap and unit vector along the y-axis is j cap, unit vector along the z-axis is k cap, unit vector along the z-axis is k cap. So, unit vector along the z-axis is k cap. So, now if you take the different kind of vectors, so one is the unit vector along x-axis, another one is unit vector along y-axis. What is the angle between these two vectors? I cap and j cap. This is theta. Theta is equals to 90 degrees. Even if you consider the angle between these two vectors, j cap and y cap, it is also 90 degrees, and angle between this I cap and k cap is also 90 degrees. J cap and k cap is also 90 degrees there. Suppose if these different kind of vectors are multiplied, then like this, I cap dot j cap. So, according to the formula, we can write there product of magnitude of the product of these two vectors, unit vectors. We know that magnitude of the unit vector is 1 into magnitude of the unit vector j cap is 1 and the angle between them. So, cos theta, cosine angle will be here cos theta. Cos theta how much we got there? 90 degrees, no? This is a 90 degrees. So, 90 degrees means cos 90 value how much? Cos 90 value will get cos of 90 degrees. Cos 90 degrees will get 0. So, this value will get here 1 into this is a 0 since cos 90 degrees is equals to cos 90 degrees is equals to 0. Cos 90 degrees is equals to 0. 0. Okay. So, we will get here 1 into 0, we will get there 0 there. So, I cap dot j cap is equals to 0. Similarly, we will get j cap, similarly j cap or dot k cap is equals to 0 and k cap dot I cap is also equal to 0. Okay. So, that means the unit vectors of same kind will get 1 and the unit vectors, the product of dot product of same kind of unit vectors is 1 and the dot product of different kind of unit vectors is equal to 0. Okay. So, now we will see the example how we have to do the dot product of the given vectors. Okay. By taking the example, we are going to see there. Okay. So, let us consider, it's completed, note it down. Yes. Now, see there next, we will take the example. Example 1, first example we will take there. Suppose, let us consider here a bar is equals to 2 I cap plus 3 j cap plus 4 k cap and b bar is equals to I cap minus 2 j cap minus 5 k cap minus 5 k cap. There are the two vectors. So, what is the dot product of these two vectors? Then find out dot product of the two vectors. A bar dot b bar is equals to how much? A bar dot b bar is equals to how much? So, we will do there here a bar dot b bar is equals to two vectors we will write as it is here. The given vectors we should write here 2 I cap plus 3 j cap plus 4 k cap and b bar dot b bar vector is I cap minus 2 j cap minus 5 k cap. Okay. So, now we have to multiply. So, like in algebra, how can we multiply there? This number can be multiplied with the whole the vector and plus the second digit will be multiplied with the second vector, and like that we'll add all of them there. So then here we can write 2 I cap into I cap. How much we get there? 2 I cap into I cap. 2 I cap into I cap there. So here 2 into 1. The coefficients here, coefficient is here 2 and here it is 1, the 1. Coefficient is 1 here. This is a coefficient here 1. So 2 into 1 will get there 2 into j cap dot I cap minus 3 j cap into minus 2 j cap. We will get this one. Then 3 j cap into minus 5 k cap. So 3 into 5 will get minus 15. 3 into 5 minus 15. Here we will get there j cap dot k cap. J cap dot k cap. So next plus we will get here next with this. So k 4 k cap 1 I cap. So we will get there 4 into k cap dot I cap. K cap dot I cap. So here this one 4 k cap into minus 2 j cap. So it is minus 8 k cap dot j cap. So next one is 4 k cap into minus 5 k cap. So minus 4 into 5 minus 20 k cap square. So we can see here this 4 j cap will be 0. It is 0 because I cap dot j cap will be 0 and I cap dot k cap is 0. Here j cap and j cap dot this one. These all the terms will be 0 there. And this is also 0. And what are the remaining here? So this one remaining is, so 2 I cap square, here minus 6 j cap and remaining here minus 20 k cap. So we'll get the value as, we'll get here is equals to 2 I cap square means 2 into 1 we can write now here, 2 into 1 and here minus 6 j cap square is a 1, 6 into minus 6 into 1 we can write and there minus 20 into this is a k cap whole square, k cap square is a 1. So we'll get here, so 2 minus 6 minus 20, 2 minus 6 minus 20, so minus 26 plus 2. So how much we get here? Minus 24. Minus 24 will get there. Therefore, the answer will get here a bar dot b bar. A bar dot b bar is equals to minus 24. A bar dot b bar is equals to minus 24. Okay. So simply instead of doing these all the multiplications, only we'll do I cap terms multiplication product of I cap and I cap, j cap and j cap and k cap and k cap will get there. See here 2, here will get there 2 I cap, 1 will get there. So minus 6 minus 20. So we'll get there 2 minus 6 minus 20. So minus 26 plus 2. So we'll get minus 24. So like that the product of the two vectors will be give the scalar value minus 24. Okay. So that's all for today children. Thank you.